Allotropes of carbon. Carbon is a well-known non-metallic chemical element which is present in all life forms. The element carbon occurs in different forms in nature with wide variety of physical properties. It is abundantly found in the Earth's crust. Let's now try to have a better understanding of carbon and its compounds. Carbon is represented by the symbol C. Its atomic number is 6, that is, it contains 6 protons and 6 electrons. Carbon exists in two forms, crystalline and amorphous. In crystalline solids, the constituent particles are arranged in a definite order. But in amorphous solids, the constituent particles have no definite order of arrangement. Coal, coke and charcoal are amorphous forms of carbon and diamond. Graphite and fullerene are crystalline forms of carbon. Both these forms are called allotropes of carbon. Allotropes are forms of the same element which exhibit different physical properties but with the same chemical composition. Let's now classify carbon according to its shape, structure and physical properties. Accordingly, let us understand the crystalline forms. Diamond. Diamond is the hardest crystalline form of carbon. In diamond, each carbon atom is linked to 4 other carbon atoms by covalent bonds forming a rigid 3-dimensional structure. Each C-to-C bond length is 154 pm. Diamond's density is equal to 3.5 grams per cc. Here, no electrons are available as they are involved in bond formation. Because of the absence of free electrons, diamond is a bad conductor of electricity. Diamond has a high melting point of 4000 Kelvin or more. Let's now learn about other crystalline allotropic forms of carbon in free state. Graphite. In graphite, each carbon atom is linked to 3 other carbon atoms by covalent bonds, resulting in hexagonal rings which are arranged in layers one above the other. One of the carbon-carbon bonds is a double bond, thus the valence of carbon is satisfied. Since one electron of each carbon atom in graphite is free to move about, graphite is a good conductor of electricity. The carbon-to-carbon bond length is 142 pm. These layers are held together by a weak force of attraction and the distance between the layers is 335 pm. Due to its structure, graphite is not as hard as diamond and is greasy. It is grey in color and is opaque with metallic luster. Graphite's density varies from 2 to 2.25 grams per cc and it melts at about 1800 Kelvin. We will examine another carbon allotrope, fullerene. Chemically, fullerenes are formed by the combination of a large number of carbon atoms. The first one to be identified was C60. Its structure has been established on the basis of investigations carried out by Buckminster Fuller, an American architect. So fullerenes are often called buckyballs. The shape of fullerene resembles that of a soccer ball with 6-member as well as 5-member rings. There are 12 5-member rings and 26 member rings. In fullerene, all the carbon atoms are found to be equivalent and are connected by both single and double bonds. Bond length of single bond is 145.3 pm. Bond length of a double bond is 338.3 pm. Things to remember. Carbon is represented by the symbol C. Its atomic number is 6, that is, it contains 6 protons and 6 electrons. Carbon exists in two forms as crystalline and amorphous. These forms are known as allotropes of carbon. The crystalline forms of carbon are diamond, graphite and fullerene. Diamond is the hardest crystalline form of carbon. Each carbon-to-carbon bond length is 154 pm. Graphite is not as hard as diamond and is a greasy substance. The carbon-to-carbon bond length is 142 pm. Fullerene resembles a soccer ball and has 6-membered as well as 5-membered rings.